Hey guys, I'm here to explain stoichiometry. So stoichiometry is essentially how we're going to convert from one unit of one element to another unit of another element or compound. So we're going to make an attempt at this practice sheet here. So in the following reaction, where 4 iron solid plus 3 oxygen gas yields 2 iron 2 oxygen 3 solid. Here's our reaction. So let's start with problem 1. If 40 grams of iron react, how many moles of iron 2O3 or iron 3 oxide are produced? So if we know we have 40 grams of iron, then we need to start off by converting that number to moles. So we're going to do that by multiplying by 1 mole of iron over iron's molar mass, which is 55.845 grams. Now that we've converted iron to moles, we're going to multiply that number by iron's molar ratio with iron 3 oxide. So for every 2 moles of iron 2 oxide, we have 4 moles of iron. And we derive that from the equation above. As we can see here, we have 2 moles of iron oxide and 4 moles of iron. And that will be how we get to how many moles of iron oxide are produced. So we're just going to plug this number into our calculator. 40 divided by 55.845 multiplied by 2 divided by 4. And we get approximately 0.358 moles of iron oxide. Let's move to part B. If 20 grams of iron react, how many grams of iron 3 oxide are produced? So we're going to take a similar process. We're first going to convert into moles. Then we're going to use the molar ratio. And now we need to get to grams. So we're going to take the molar ratio between iron 3 oxide. What will that be exactly? 2 multiplied by the mass of iron plus 3 times the mass. We'll expand this out. We'll move this down here. This is multiplication. Multiplying over so if I can actually maybe squeeze this in. Okay, no, I'll just leave it on here. And now if we multiply all these numbers out, we get 20 grams divided by 55.845 multiplied by 2 divided by 4 multiplied by the quantity of 2 times 55.845 plus 3 times 16. And we get about 28.60. All right, let's move to part C. If 10.0 moles of iron react, how many molecules of iron 3 oxide are produced? So if we start with 10 moles of iron, first we need to convert to iron 3 oxide, the molar ratio. Now we need to go from moles to molecules. And this is where we use Avogadro's number. So for every mole of iron 3 oxide, we have 6.02 times 10 to the power of 23 molecules. That's Avogadro's number. I should probably put molecules. And that will give us our answer. So we're going to multiply these numbers together. And you get about 3.01 times 10 to the power of the 24. All right, let's move to part D now. If 3.00 times 10 to the 22nd atoms of iron react, how many moles of Fe2O3 or iron 3 oxide are produced? So now we're going from atoms to moles. So 3.00 times 10 to the 22 molecules. I'll just put, atoms, iron. First, we need to convert this into moles of iron. How are we going to do that? We're going to do 1 mole of iron over Avogadro's number. Then we're going to convert, now that we've converted from atoms of iron to moles of iron, we're going to convert from moles of iron to moles of iron 3 oxide. And again, I'm referencing the equation on the left over here. All right, now that we have our stoichiometric equation, we can just plug this into our trusty calculator. And just give me a moment. So 3.00 times 10 to the power of 22 divided by 6.02 times 10 to the power of 23 divided by 2, divided by 4. Hold on, my calculator is having a quick error here. .02 times 10 to the power of 23. Yeah, so you get approximately 0.025 moles of iron 2 oxide. Great. Let's move on to problem 2. In the reaction for photosynthesis, 6 carbon dioxide plus 6 water yields glucose plus 6 oxygen. If 715 grams of CO2 gas is consumed, how many grams of glucose are produced? The molar mass of glucose is 180.16. So first we're going to that's an error. First we're going to convert the grams of CO2 into moles. So we have 1 mole of CO2 over the molar mass, which is just going to be 12 plus 2 times 16, which is going to simplify to 44. Next, we'll convert to moles of glucose. So for every mole of C6H12O6, we have 6 moles of CO2. Next, we're going to convert to grams. So as given in the problem, we know the molar mass is 180.16 grams over 1 mole of C6H12. Actually, I should write that here. And that is all the calculating we need to do. So let's plug this into our calculator. 715 divided by 44, divided by 6, multiplied by 180.16. And we get about 487.93 moles. All right, let's try problem B for 2. How many molecules of carbon dioxide are required to produce 5.9 times 10 to the 24th molecules of oxygen gas? So, if we have 5.9 times 10 to the 24th molecules of oxygen gas, we first need to convert that into moles. How will we do that? We will simply use Avogadro's number. So we have 1 mole of O2 over 6.02 times 10 to the 23rd molecules of protein. Then we will use the molar ratio to go from moles of oxygen gas to moles of carbon dioxide. So 6 moles of carbon dioxide over 6 moles of O2. Lastly, we'll convert the 6 moles of carbon dioxide into molecules. And so we'll use 6.02 times 10 to the 23rd molecules. I'm just going to shorten that. Over 1 mole CO2. And now we just plug this into our calculator, and we get 5.9 times 10 to the 24th, mainly because in this scenario, we are able to cancel out Avogadro's number, and this also cancels out to 1. So you just end up getting what we started with, which is 5.9 times 10 to the power of 24th molecule CO2. Thanks for tuning in. I hope this was a helpful lesson.